Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Sekejap, macam tak ada sound lah. Sound dengar ke? Can you guys hear me clearly? Boleh dengar ke? Suara okey? Okay, so jom start lah dengan chapter 9, random variable, because as soon as we start, as soon as we finish, and then as soon as we can go and have our lunch or our breakfast. Okay, so now we have a few learning outcome for today. At the end of the lesson, you should be able to define discrete variable and then construct the probability distribution table and probability distribution function as well as the graph, and then find the cumulative distribution function. So our focus for today is firstly on the introduction to random variable and then with discrete random variable. So until the second lecture, we are going to do the discrete random variable, where I think in this lecture I'll proceed until the expectation as well as the variance. Okay, so let us start with lecture 1. But before that, good morning, Farha. Okay, next. Right, so what is variable? Variable was defined as a characteristic or attribute that can assume different values. Various letters of alphabet such as X, Y, or Z used to represent variable. So the first example, if let's say a die is rolled, a letter such as X can be used to represent outcome. So what outcome when we roll a die? So of course, the outcome is 1, 2, 3, 4, 5, or 6. Correspond to the outcome of rolling of a dice. So yang atas ni lah. So this is outcome. So X can 1, 2, 4, 5, 6. Okay, so the second example, if coins are tossed, a letter Y can be used to represent the number of head, in this case 0, 1, 2. Okay, so why do we have 0, 1, 2? Basically, you toss your coin twice. Okay, so the first one, you might get a head or a tail. The second one, also a head, tail, a head or a tail. So basically, this is head, head, tail, tail, head, tail, tail. Okay, the letter Y is the number of head. So for example, here the number of head is 2. The second one, the number of head is 1. The third one, the number of head is 1. The last one, the number of head is 0. So that is why we can say the letter Y in this case can be used to represent the number of head, which is either 0, 1, or 2. Okay, so since the variable are associated with probability, they are also called the random variable. Okay, a random variable is a function that assigns a numerical value to each simple event in a sample. Okay, so usually random variable are denoted by the capital letter X. So X is the random variable and Y is the random variable. So normally if you see capital letter, so cap X, cap Y, so those are the variable. And the small letter, so the small X and Y are used to represent a particular value of the random variable. Okay, so example 1, 2 coin are tossed and a letter X toss pula lah, toss. 2 coins are tossed and the letter X is used to represent the number of head. Okay, so the possible outcome, this is T, H, T, TH, and HH. So X is the random variable where X is the number of head. So in TT, we have 0 head. In HT, we have 1 head. In TH, we have only 1 head. In HH, we have 2 head. Okay, therefore, the possible value of x, so x is the random variable, and x is the particular value for that random variable. So the small x is either 0, 1, or 2. Okay, so next. Random variable, so we can have two type random variable. We can have a discrete random variable, or we can have a continuous random variable. Basically, today is all about discrete random variable. Okay, so discrete random variable, that is a values can be counted. So some example of discrete random variable are the number of car sold at a dealership during a given month. Of course, can have a value straightforward. So kita tak ada point-point, so value that can be counted straight away. The number of employee, again a human person, we cannot have a quarter or half employee. The number of complaint received at the office of an airline on a given day, again the number of complaint. When we are talking about the number of complaint, you either receive 2 complaint, 3 complaint, 4 complaint, 5 complaints. You never say 3.133 complaints. The number of customer, again, this is the number of persons, so you not have any decimal place, right? So the number of customer visiting a bank during any given hour. So we can either have 10 customers, 20 customers, 30 customers, and so on. And then the last one, the number of head obtained in 3 tosses of a coin. So you can either have 0 head, 1 head, 2 heads, or perhaps 3 heads when you toss coins consecutively. Okay, next. A continuous random variable. So these are the value that are not countable, so we cannot count like these. So we definitely going to have either one or more interval for them. So for example, the salaries of a worker in a factory, we can say between 5 to 7 time taken by workers to learn a job. So some worker might take around 15 minutes to learn a new thing. Some worker might take around 1 hour to a new thing. And even within those hour, you can say that 1 hour, 6 minutes, 30 seconds, 1 hour, 6 minutes, 25 seconds, and so on. So we can have all the interval. The amount of water or water, the amount of water consumed by a family in each month of a year. So boleh cakap 3 liter. 3 liter macam sikit gila. Berapa? Yeah, one day it should be 3 liter. Right? So a month around 90, 12. Okay, let's say I give them around 1,000 liter. Then another family might use 1,000.1 liter. And then the height of student college, of course, you can put them in an interval. For example, 183.56, 183.5, 183.6, and so on. So they will have some interval for the height of student. Okay, so now today we are going to focus on the discrete random variable. Okay, so probability distribution of a discrete random variable. So this is the list of all possible values of random variable x with a corresponding probabilities. So this is known as the discrete probability distribution. Okay, so we need all possible values of x together with their probability. Okay, so the summation from I equal to 1 up until k, px equal to xi, where x is known as the discrete random variable. The probability over here should be in between 0 until 1, of course, including 0 and 1 as well. So it should be somewhere between 0 and 1. And if you total up all the probability, they should be equal to 1. Otherwise, this is not a discrete random variable. So if I can draw for them, let's say this is x and this is probability of x equal to x. Then if I add everything together for the probability, the summation should be equal to 1. So if I add all probability, they should be equal to 1. So that is what they mean over here. Next, let us go to one example. Okay, so the probability distribution can be represented in a table format, a function format, or a graph format. So the table is the one I showed you before, where you have something like x and then p, x equal to x. So these are the table. So function, we're gonna write down p x equal to x and then give the set notation for them. And then these are the probability. And then this one might be when x equal to 1 or x equal to 2 and then maybe 0 otherwise. So this is the function. If you have the set notation, those are for the function. The probability graph, so it will look like this. So this is for x, p is equal to x. So perhaps when x equal to 1, the probability is 1 over 2. So you're going to draw this kind of graph. When x equal to 2, probability perhaps 1 over 4. So something like this, a vertical line. What do I mean is simply a vertical line. So those are for the graph, probability distribution, but in a graph format. Okay, so we can represent them using three form. So either you can use a table, you can use a function, you can use a graph. Normally, question will specify whether do they want a table or do they want a graph or do they want a function. Normally, the question will say, what do they want? Okay, let us go to the second example. Okay, construct the probability distribution function if two fair coins are tossed. Sketch the graph of probability distribution function. Okay, so I need to construct the probability distribution function. So firstly, let us draw the tree diagram first because we have to calculate the probability. Okay, so the first one, we either get a head or a tail. So this is for the first toss. So you can either get a head or a tail. And then for the second one, because you have two fair coin. So this is for the second one, head or tail again. Perhaps this one is better for first coin and second coin, right? Second coin, head and tail again. Okay, so what is the probability that when you toss a coin, you are going to get a head? So the probability is simply 0.5. So they didn't really mention. They say over here that this is supposed to be a fair coin. Fair tu bukan putih, fair tu maksudnya adil. So a fair coin simply mean that the chances for me to get a head and the chance to get a tail is similar. Where in this case it's supposed to be 1, 2 because we have only 2. So this is half, this is also half. So the chances to get a head is 0.5. Chances to get a tail is also 0.5. For the second coin, we also have a similar probability. The chances to get a head is 0.5. The chances to get a tail is 0.5. This is also 0.5. This is also 0.5. Okay, so the first coin we get a head, second coin we got a head. So this is head, head, or H. And then this is H, this is tail, H, tail. This is tail, that is H, so T, H. This tail, this also tail, so this tail, tail. So let's say the X represent the number of tail. Okay, so if let's say X represent the number of tail, so let us do X over here. So X is the number of tail. So H, I don't see any tail, so this is 0. So this is for X equal to 0. And then H tail, that means this is for X equal to 1. TH, I have one tail, so this is X equal to 1. Tail, tail, that means I have two tails, so this is 2, X equal to 2. Okay, therefore, the X is either equal to 0 or X equal to 1 or X equal to 2. Okay, so perhaps you can easily calculate the probability later on. Okay, so what is the probability to get a head and a head? So it's supposed to be 0.5 multiply with 0.5. So the chances for this one is 0.5 times with 0.5. which is 0.25. And then to get head and tail, again, that is 0.5 multiplied with 0.5. And then in order to get a tail and a head, that is also 0.5 times with 0.5. This is also 0.5 multiplied with 0.5. Okay, so now let us do the table for them. Okay, imagine we have x over here. This is probability for x equal to x. So like I told you before, the x can go from 0, 1, and 2. So we can either have 0 tail, 1 tail, or 2 tails. Okay, so how to obtain 0 tail? So to obtain 0 tail, the only possibility is when I have head and head. So this is 0.5 multiplied with 0.5. Of course, you can use a fraction as well. So half times half. So this is 0.25 or 1 over 4. Okay, so how do we obtain x equal to 1? So there are two ways to obtain x equal to 1. So we can either get a head and a tail or tail and a head. So there are two probabilities. First one is 0.5 times with 0.5, which is another 0.4, 1 over 4 or 0.5. But then we do have another one where we have 0.5 times with 0.5. So this one you should add them together. So this is all the possibility to obtain x equal to 1. So the first one comes from the head and tail. The second one comes from the tail and head. Okay, so the second one, not the second, the last one, how to obtain two tails. So basically, both of them should be a tail. So 0.5 times with 0.5. So the chances to get two tails is simply 1 over 4. Okay, so let me write them down in a much more neater table. Sebab nampak macam mas kan. So kita buat table cantik sikit. So this is table. So x, px equal to x, 0, 1 over 4, 1, 1 over 2, 2, 1 over 4. So let me remind you, how do you get 0? So this is for h, h. So this is for tail, h, h, tail. To get 2, this is supposed to be tail and tail. Okay, x, p, x equal to x. So this is how we represent them in a table format. Since the question asks for a function, let us draw the function. Okay, so we are going to get half when x is equal to 1, and then 1 over 4 when x is equal to 0 or 2, and then you need to add another one, 0 otherwise. What does 0 otherwise mean is that other than x equal to 0, other than x equal to 1, other than x equal to 2, I don't have any probability left. So all my answer are around here only. Okay, so half for x equal to 1, 1 over 4 for x equal to 0, as well as x equal to 2, and then 0 otherwise, or if you don't want to write down otherwise, you can use elsewhere as well. So elsewhere pun boleh jugalah, mana je lah. Okay, so that is the second one. And then they were asking us to draw the probability distribution graph. So make sure to have the graph. Okay, so this is for x, the y will be for the probability distribution. Okay, so based on the value, we have 1 over 2 and 1 over 4. So definitely 1 over 4 at the lower value, 1 over 2 at the higher value. Okay, so we have x equal to 0, 1 and 2. So do make sure to write them down in the x. So 0, 1, 2. The probability is 1 over 4 and 1 over 2. So the lower is 1 over 4, the higher one is 1 over 2. And then of course you can draw the vertical line. So this is probability distribution graph. So that is the reason why we are having some vertical line. Okay, so when x equal to 0, the answer is 1 over 4. So those are the vertical line. When x equal to 1, the answer is 1 over 2. So those are the vertical line. And then when x equal to 2, the answer is 1 over 4. So that is the vertical line. So yang ini kena tajam sikit lah, tebal sikit dia punya garis tu. Make sure you can see this. Okay, so ini kena sikit lah. Bukanlah scale apa, maksudnya kena follow number lah. Nombor yang kecil dekat bawah, nombor yang dekat atas. The same thing with the X, you must follow some scale. Kena ikut susunan nombor lah in ascending order. Okay, so this is how we represent probability distribution. So you can either use a function or you can use a graph. Okay, next. The probability distribution function of a discrete random variable x is given by px equal to k for minus x. This is for x equal to 0, 1, 2, 3. Given that k is a constant, find the value of k. So this is mostly when we want to start with our random variable. We have to find out some constant. Okay, so what should we do? Every time I have a discrete random variable, I prefer to draw a table for them straight away. And then the first one is for the x, the second one is for the px equal to x. So they already mentioned over here the x is 0, 1, 2, 3. So let me write them down in my table. And then the second one is for probability for x equal to x. So what you are going to do now is that you're going to simply substitute the value of x inside the function over here, k for minus x. So substitute the value of x here with either 0, 1, 2, and 3, and write down whatever value that you have below here. Right, so I'll give you 1 minute for you to write them down. Let me naik sekejap. Kenapa macam tak clear? Okay dah. Right, so now let us see what happened when we substitute the value of x. Okay, so when equal to 0, we are going to get 4 minus 0, which is simply 4. So 4 times with k, that will become 4k. And then if you substitute with x equal to 1, you are going to get 4 minus 1, which is 3. 3 times k is 3k. Substitute x with 2, so 4 minus 2 is 2. 2 times k, that 1 will become 2k. Substitute x with 3, so 4 minus 3 is 1. 1 times k is simply k. Right, so what did I mention earlier is that if this is a discrete random variable, I did mention, right, if I add all the probability here, altogether they should be equal to 1. So basically, since this is a discrete random variable, if I add all the probability, they should be equal to 1, which means that if I have k plus with 3k plus with 2k plus with k, altogether should be equal to 1. So 4 plus 3 is 7, 7 plus 2, 9, 9 plus 1, so this is actually 10. So 10k is equal to 1. So that means k is simply 1 over 10. So that is basically how we can find out some constant for the discrete random variable. So always make sure when we have a discrete random variable, it will be better if you draw your table first and then see what do you have then, and then the probability, if you add all the probability, summation of the probability all together, they should be equal to 1. Okay, next. Right, so now we are going to learn about the cumulative distribution function. Okay, so just like the word itself, cumulative, that means we are going to accumulate from the beginning until a certain value of x, and then we're going to see what is the value. Of course, higher value should be equal to 1 because the the total probability should be equal to 1. So obtain, so the cumulative distribution function, this is obtained from a frequency table by summing up all the frequency or probability up to a particular value. The resulting function is cumulative distribution function. Right, so if x is a discrete random variable with the distribution function px equal to x for x equal to x1 and x up until xn, then the cumulative distribution of x denoted by cap f. So again, we are using the cap f for the relative distribution function similar to data. So this is given by, so the cap f is simply the probability for x less than or equal to x. So this is the summation from x equal to x1 up until xn for probability of x equal to x. Okay, so that means we're simply going to add all the x up until over here, up until that point. Okay, so let me see some example. Okay, so one, the median. What is a median? Median is actually the value when probability for x or equal to m is equal to 0.5, or since the probability for x less than or equal to m is simply equal to fm, then therefore fm is also equal to 0.5. Okay, next. The probability distribution of a discrete random variable x given in the table below. So we have a table over here. These are the probability. So when x equal to 0, we got 1 over 8. Probability for x equal to 1, 3 over 8. Probability of x equal to 2, 3 over 8. Probability of x equal to 3 is 1 over 8. And the question wants us to find the cumulative distribution function. And then they want us to sketch the graph for cumulative distribution function. Right, so do make sure this is different from the graph that we did earlier. Before this, we are sketching the graph probability distribution function. This is cumulative distribution function. So the graph will be slightly different. And then they want us to know what is median. Okay, so now how to find the cumulative distribution function? So we have to refer to the table. Okay, so f of x, so this is probability for x less than or equal to x. So that means I'm going to add everything until I reach x. So for example, for x less than 0, so the first number I see is 0 over here. So let's say I start with x less than 0, then the cumulative is simply equal to 0 because we haven't reached x equal to 0. Okay, so x is greater than or equal to 0 and less than 1, then f of x is simply equal to probability for x equal to 0. Okay, so before we start, the cumulative should be equal to 0. When we start directly at 0, the probability should be equal to 1 over 8. And then for the next one, x greater than or equal to 1 less than 2. So x greater than 1 less than 2. So this is probability of x equal to 0 plus with probability of x equal to 1. So you're going to add everything together. So 1 over 8 plus with 3 over 8. So it will become 4 over 8. So 4 over 8. So simply add everything together. And then the next one. for x greater than or equal to 2, less than 3. So we're going to do probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. 1 over 8 plus 3 over 8 plus another 3 over 8. So this one will become 7 over 8. Now the last one, so this is 7 over 8. The last one, x greater than or equal to 3. So this basically equal x equal to 0 plus probability of 2 plus probability of x equal to 1 plus with probability of x equal to 2 plus probability of x equal to 3. So 1 over 8 plus 3 over 8 plus 3 over 8 plus 1 over 8. So the answer for this one is simply equal to 1. So that is basically total probability. You should stop when you reach 1. That is already okay. If let's say you calculate and suddenly you get something that is more than 1, then do check again. You might done wrongly. Bukan might lah. Sepatutnya lah you are adding wrongly. Okay, so I already have the function and the value. So this is interval and the value, interval and the value, interval and the value, interval and the value. So now let me write them down in the function format where I have the set notation. Okay, so when x less than 0, 0, 1 over 8, x then or equal to 0, less than 1, 4 over 8 for x greater than or equal to 1, less than 2, 7 over 8 for x greater or equal to 2, less than 3, 1 for x equal to 3. So you simply take the interval together with the cumulative distribution function. So 0, 1, 2, 3. Okay, so basically, you can see here we have probability for x equal to 0, x1, x equal to 2, x equal to 3. So now see how many interval do we have? 1, 2, 3, 4, 5 interval. So 1, 2, 3, 4, 5. So always check, since you are having 4 of x, just you are supposed to have 5 interval. So always check. You must start from and you must end with 1. It is a must. Okay, so now let us the cumulative distribution graph. So they will be different from the probability distribution graph. So basically in probability distribution graph, we will have those vertical line, right? So for the cumulative distribution graph, we will have a horizontal graph, or normally called as the step graph. Okay, let us start with the lowest value, which is x less than 0. So the value of the cumulative function is also 0. Okay, so this is basically the graph. Do make sure to use an open circle, because for this one, it is not including 0. Not including 0, so starting from 0 and going to the left hand side, it will be a flat graph of a horizontal graph, 0. And then 0 up until 1, value is 1 over 8. So this 8, 4 over 8, 7 over 8, and 1. And then we have something from 0 to 1. Okay, so of course at 0, it should be a dense circle. Asal lah dia mesti tak nak kasih saya buat dense tu. Okay. Right, so it should be a dense circle at 0, and then going 1, and then a flat 1 at 1. And then of course you're gonna have a dense at 1 and open 2. So the y value is 4 over 8. Since this one is not that big, So saya buat besar sikit lah. Okay, next. The next step is 8. And then the last one is for x squared or equal to 3. So it will be an arrow going to the right hand side. So we start from 3, going to the right side. This is going to. Okay, so that is basically for the cumulative distribution function. Okay, so like I told you before, they look like a stack macam tangga lah. Dia ada macam naik turun macam tu. Yang kalau saya tambah titik-titik sini memang jadi macam tangga lah. That is why I love as the step one. The step graph. Dia kena macam tangga. Okay. So, you guys nak lukis dulu kan? Ataupun screenshot dulu lah. Screen dulu. Nanti kita boleh patah balik yang ini. Untuk awak lukis kan. Right, the next one, we have to find what is the median. So this is the graph. We want to find where is the median. So what is the definition of median? So median is when Fm is equal to 0.5, or you can say that probability of x less than or equal to m must be equal to 0.5. 0.5 is also 1 over 2. So on the left hand side and the left hand side and the right hand side, do check when can you get a half. Okay, so the answer is and m equal to 1. Okay, f of 1 is equal to 0.5, like you can see over here. So this is when x is 1, 4 over 8 is simply 1 over 2. So f of 1 is equal to 0.5, therefore the median is simply equal to 1. Okay, so let me do one more example and then proceed to the next lecture. Okay, next. So the cumulative distribution of a random variable x is given in the table below. So we are given the cumulative distribution now, and then they want us to find the probability distribution table of x and find out. Okay, so what is the mode? So based on the data, for the mode, we have the highest frequency. So the highest frequency means that you are going to have the highest probability as well. So the highest frequency simply means that we are going to get the highest probability. Okay, so therefore, from the probability distribution table, we're going to see where can we get the highest probability. Okay, so how to get probability distribution table? It is actually almost similar to what we have in data. We simply minus everything altogether. So let us see how to do that. Okay, so the value for Px equal to x for x equal to 1, 2, 3, 4, and 5 are calculated with P of x equal to A is simply equal to probability for x less than or equal to A minus the number before that. I mean, if you want to calculate probability for x equal to 1, this is probability for x less than or equal to 1 minus probability for x less than or equal to 0. So x less than or equal to 1, that is this number over here. So the probability is 0.05. Probability for x less than or equal to 0, I don't see any 0 over here. So the probability is simply equal to 0. So that probability to get x equal to 0 is the probability for x equal to 1 is simply 0.05. So we are going to do the same thing to calculate probability for x equal to probability for x equal to 3, probability for x equal to 4, as well as probability of x equal to 5. So kita akan tolak yang sebelum untuk probability. Okay, x. Okay, so this one I already calculate them before this. So the probability of x equal to 1 is simply 0.05. Okay, so let me write down over here px equal to x. So this is 0.05. Okay, so how do we get probability for x equal to 2? So it should minus this one, right? So 0.3 minus 0.5. So 0.25. And then how do we get probability for x equal to 3? Of course, 0.6 minus with 0.3. So it will become 0.3. How do we get probability for x equal to 4? So from here, we minus 1, the previous one. So 0.75 minus 0.6. So it will become 0.15. And then the last one for probability of x equal to 5. So you're going to simply take this probability, the cumulative minus with the previous cumulative. So 1 minus 0.75. So the answer is 0.5. Okay, so the question asks for us to write them down in a table. So I will write down the x as well as my px equal to x in a new table so that it look much more neater. Yang ini cara je tau, cara nak kira. Oops. You must always minus with the cumulative for you. Okay, so I'll give you around 2 minutes just in case someone want to copy down something. Okay, so this is the probability distribution table of x. So this one look much more neater compared to the one that I used before. Okay, so now we have to find out the probability distribution table of x. So now the next question, what the can you tell me? Bagi respon sikit lah, 1 minit lah, 43 minit lah. I didn't hear any response. Okay, so now what is the mode? Is the mode 1 or is it 2? Is it 3? Is it 4? Or is it 5? Where is the mode? Di manakah mode? 8? Right, so thank you for the response. So the answer is 3. So you are correct. Why is it 3? Because it has the highest probability. Okay, so mode is 3. Right, so notice that if you add all probability, it should be equal to 1 because this is a discrete random variable. So if we all the probability, they should be equal to 1. Aha, you are correct as well. So Pong dengan Farha dua-dua betul lah. Jawapan dia adalah 3. Very good. Okay, so done with the first lecture. So now let's proceed with the second one. Okay, so the second one, we are still at the discrete random variable. So at the end lesson, you should be able to find the probability from probability distribution table or function. So if let's say I give distribution table, how can you find the probability for each of the x? And then from the cumulative distribution function, how can you extract that information? Okay, so the second one, find the addition and variance of a discrete random variable. So yang A tu macam yang lecture tadi sebenarnya. Yang baru sikit expectation dengan variance tu lah. Okay, so now this is the formula or the formula. Okay, so the first probability for x equal to A. So this is probability of x less than or equal to A minus probability of x less than or equal to A minus 1. But this one is actually the definition for FA and this is actually definition for FA minus 1. So that means if let's say you have probability for x equal to 3, so the way to find them is simply take that number minus with the previous one. So f of 3 minus f of 2. Like what we did earlier. Sebab sebelum ni pun soalan dia lebih kurang macam lain. Sama je lah. Kita ambil yang dia, kita tolak yang sebelum daripada dia. Cuma ini kita nampak dalam bentuk formula sajalah. Okay, so this is, I do feel that this is the easiest one. Dia agak straightforward sebab kita bagi cumulative and then kita cari saja. Okay, so what happen if we have thing in between? Okay, so if let's say you want the probability for x to be greater than A, and this is actually 1 minus probability of x and or equal to A. Okay, so imagine you have A, this is A, you want greater than A. So what did you do? You're gonna take all the probability because all the probability is in prime, and then you're gonna minus with probability of x less than or equal to 1. Oh, dia tak bagi saya buat lurid. Sabar je lah. Never mind, you get the idea. Okay, so probability for x greater than a. So this is simply the total probability is 1 minus with probability of x less than or to a. Okay, so why do we want to use probability of x less than a? Because that is actually the definition of the cumulative distribution. So x less than or equal to a. So this is simply equal to f a. So this is 1 minus f a. So if let's say you want to calculate probability for x greater than 4, so simply take the total probability 1 and then minus with the probability for x less than or equal to 4, which is f of 4. Okay, the next one. Right, so if let's say you want something in between, so x will be greater than a but less than or equal to b. Okay, so imagine having a number line, something like this. So a on the left hand side, b on the right hand side. Okay, so cumulative always start from the left hand side. So we want a until b. Okay, so I need to make sure I take the bigger first. So I'm going to start from the left hand side until I reach B because I do B. So I have to start from the left up until B. So this is for x greater than x less than or equal to B. But from here, I don't want the A. Therefore, I should start from the left hand side up until A. So I'm gonna minus the A as well. So bila tolak A tu takkan ada dah lah. Sebab dekat sini dia kata tak boleh ada equal kan. So I don't want the A. So I'll take probability from the left hand side up until P. And then I'm gonna minus with the probability from the left hand side up until A. So what I will have left is the next one, which is A plus 1 up until B. Okay, so for example, if let's say x in between 5 and 7, okay, so let me erase that so that we can see them much more clear. Okay, let's is 5, 6, 7. Okay, so we do have some value at 5, some value at 6, some value at 7. Okay, I don't want them at 5, but I want them at 7. Sebab saya tak boleh buat bulat yang tu tau. Sebab tu saya buat garis macam ni tau. Ish. Okay. Right. So I don't want 5, but I want 7. So always start from the left hand side, taking everything up until 7. And then the only thing that you want over here is 6 and 7. I don't want a 5, so I should deduct 5. So until where you, and then deduct the number that you don't want. Okay. Next. Right. So let's say x in between A until B. Okay. If we draw a number line, this is A, this is B. So open at A, open at B. Okay, so I want B, so that means when I start, I should start at B minus 1. So we should start from the left hand side up until B minus 1. So this is the number that I want, B minus. And I don't want to have A as well, so I should start from the left hand side and deleting A. So I will have whatever left in between here. That is why we are having x less than or equal to b minus 1 minus probability for x less than or equal to a. Okay, so for some example, if let's say I want, so this is 4, this is 5, this is 6. So somewhere in between 4 and 6. Right, so the cumulative always has the equal sign. So whenever you start from the left hand side, always go until the equal sign. Okay, so I will start from the left hand side and stop at 5. Why I didn't stop at 6 is because I don't need the 6, I need the 5. Okay, and then I don't need 4. So that is the number that I should reject. So kita akan dapat kawasan tu je lah nanti. Okay, next. So probability for x greater than or equal to A, less than or equal to B. Okay, so now this is A, this is B. Equal A, equal B. Okay, so always start from the left hand side. I want the B. I have to go up until B. And since I want the A, the number that I don't want is actually A minus 1. So you kena tolak yang belakang lagi lah. Barulah you hanya akan dapat A until B. So it's supposed to be P x less than or equal to B minus probability for x less than or equal to A minus 1. So FB minus FA minus 1. So if like we have some example over there, 2 until 6. So let me show you with that example. Okay. 2, 3, 4, 5, 6. Okay. What do we want? I want the 2 and the 6. So when we start from the left hand side, go straight away to the 6. So this is why we have f of 6. And then I want the 2 as well. So I cannot minus f2 because I'm deleting the 2 as well. So I should minus the one before the 2. So the number is 1. So I will delete from the left hand side up until 1. So that I will be left with 2 up until 6. Okay, so hopefully get that. So now we're going to do calculation for them. Okay, so a fair die is roll. Okay, so what does a fair die mean? A fair die means that the die is fair, so the probability for us to get any outcome is similar, so the chances is same, where chances for us to get 1 is 1/6, the chances for us to get 2 is also 1/6, 3 1/6, 4 1/6, 5 1/6, 6 1/6 as well. Okay, so if x represent the number on the die, show that x is a discrete random variable, and then you have to find the probability x greater than 3 as well as the probability for x in between 1 and 5 including 5. Okay, so let us draw the table. Okay, so the possible values of x are 1, 2, 3, 4, 5, 6 because this is a fair die. Of course, the number will be 1 until 6. Okay, so we have the probability Px equal to x. Like I told you before, this fair die, so the chances will be similar everywhere. So 1/6, 1/6, 6, 1/6, 1/6, 1/6. Right, so basically to check this discrete random, there are two things that you need to check. One is that the probability should be in between 0 and 1 only. So you cannot have any number and a number that is bigger than 1. So things is okay. The second one, you must make sure that if you total up all the probability, they should be equal to 1. So now let us test the second condition over there. So if I do 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus another 1/6, so it's supposed to be 6/6, which is simply equal to 1. Say that x is a discrete random variable. So how do I know x is a discrete random variable? There are two things that you have to check. The first one, the probability cannot be negative and cannot be more than 0. The second one is that if you add all the probability, they should be equal to 1. And then you can say that x is a discrete random variable. Okay, so now find probability of x greater than 3. Okay, so we need to refer to outcome that will give us a number that is greater than 3. So what are the numbers that is greater than 3? So the numbers are 4, 5, and 6. Therefore, the probability of x greater than 3 is simply probability for x equal to 4 plus probability of x equal to 5 plus probability of x equal to 6. So what is the probability for x equal to 4? 1 over 6. Probability for x equal to 5, 1 over 6. Probability of x equal to 6, 1 over 6. So you're going to add everything together. So 1 over 6 plus 1 over 6 plus 1 over 6. So this is 3 over 6 or 1 over 2. Okay, the second one, we have probability 1 x less than or equal to 5. Okay, so I'll give you 2 minutes for you to see or to find out what is the value of x such that x is greater than or equal to 5. And then you can add all the probability together. And please let me know what is your answer in the chat box. Chat box kita panggil live chat. Lapar lah, tak makan lagi. So remember to list down all the numbers that is greater than 1 and less than or equal to 5 first, and then add the probability together later on. Dua per tiga Khamis. Okay. Tak apalah, kita tengoklah jawapan. Dapat 2/3. Okay. Orang lain semua dah siap? Dapat jawapan yang sama ke? 2/3 juga. So kalau tidak, saya macam bagi masa untuk kira sikit. Sebab asyik dengar saya cakap je macam bosan je kan. So at least korang boleh kira dulu, tengok macam mana, dapat ke tak. Ada masalah ke, ada tak faham ke, senang sikit kalau nak explain balik apa ke. Okay, firstly, we're gonna list down what is the x such that it is greater than 1 and less than or equal to 5. So we are going to start with x equal to 2. X equal to 2 plus x equal to 3 plus x equal to 4 plus with x equal to 5. And then you're going to do 1 over 6 plus 1 over 6 plus 1 over 6 plus with 1 over 6. So altogether is simply 2 over 3. So untuk siapa yang dapat 2 over 3, tahniah untuk semua yang dapat 2 over 3. Tahniah bukan tahniah sebab apa, berjaya follow lah. That's really nice. If you can get 2 over 3, that means you can understand a few things. Alright, next. Right, so this is the cumulative distribution function of discrete random variable x. So we got x equal to 1, 2, 3, 4, 5, fx equal to 0 0.2, 0 0.32, 0 0.67, 0 0.90, and then 1. Of course, you have to find out probability for x equal to 3, x greater than 2, x in between 2 and 4 inclusively, and find out where is the median. Okay, so now saya tahu you can actually use the method that you learned previously where you calculate probability for x equal to x. So it is 0.2. This one, if you minus them, 0.12. This is 0.35. This is 0.23. And then this one is 0.1. And then you can get the value straight away. I'm sure about that. But let us try to use the formula that I read with you before. So formula yang panjang tu yang ada A, ada B, ada A-1, B-1 tu kan. So let's try to use that formula. I'm going to do this straight away if you use the method you learned previously. Number 1 yang tu boleh dapat terus, tapi saja je lah kita try guna cumulative. Okay, next. So I want to get probability for x equal to 3. So based on the that we have for the first one, probability of x equal to a is simply probability for x less than or equal to a minus probability of x less than or equal to a minus 1. Or we are going to say fa minus fa minus 1. So probability of x equal to 3. So this is 3, this is 3, 3 minus 1, that is 2. So this is f3 minus f2. F of 3, the value is 0.67. F of 2 is 0.32. So the minus them. So this is 0.35. So we have tried to use the first formula. So let us proceed with the second one. Okay, so probability for x greater than 2. So you must remember one thing. For cumulative, we always start from the left hand side. So this symbol over here cannot be greater than, it should be less than. So I should 1 minus probability of x less than or equal to 2. Or you can refer to this formula, probability of x greater than a is 1 minus probability of x less or equal to a. So x greater than 2 is simply 1 minus probability of x less than or equal to 2. So now we can use the cumulative because this is simply f2. So f2, the value is 0.32. So 1 minus 0.32, which is 0.68. So that is for B. So now C. C is the probability for x into and 4 inclusively. Okay, if you don't remember the formula, so we have 2, 3, 4. So I want from 2 up until 4. So firstly, I should take the probability from the left hand side up until 4 first because I want the 4. And then since I want the 2, I cannot delete the 2. I should delete the 1 below that, which is 1. So from the left side up until 1 so that we can have the 2, 3, and 4. Okay, so if you refer to the formula, it will become probability for x less than or equal to a minus probability of x less than or equal to a minus 1. So this is fb minus fa minus 1. So this is f4 minus with f1. F4, so this is 4, the value is 0.9. F1, So this is 1, the value is 0.2. So 0.9 minus 0.2, so the value is 0.7. Okay, let's see. Do we have another one? Yes, we have the median. Okay. Right, the median. Okay, so what is the definition of the median? The definition is that probability for x less than or equal to m is supposed to be equal to half. Okay, so x less than, oops. Okay, the median is the value when probability for x less than or equal to m is equal to 0.5 or f of m is equal to 0.5. Okay, so now where can 0.5? So up until 2, I get 0.32. So that means if I want to get 0.5, it should be somewhere inside. So the answer is simply x equal to 3. Hari ni macam sensitif semacam lah. Welcome. Okay, so that is the median. Next. Expectation. Okay, so this is quite new. Expectation as well as the variance. Okay, so please listen carefully. How are we calculate expectation and how are we going to calculate the variance? So basically, in order to calculate the variance, you will need to calculate two expectations. So do make sure you understand what is this expectation first. Okay, so x or the expected value of a random variable x is simply the mean of x and denoted by mu or ex. If x is a discrete random variable with probability distribution function px equal to x, then the expectation of x is simply the summation of x times with px equal to x. So this is the reason why for a discrete variable, I prefer to write them down in a table format. Because if I write them down in table format, in order for me to calculate the expectation, so I simply times the x with the probability, x with the probability, x with the probability, and then I simply add everything together. So those are my expectations. Okay, so expectation of any value of x. So the definition of expectation is ex equal to x multiply with px equal to x. So kalau tak nak tulis xi sampai k tu, you can write down all x. So the summation of all x for x times with px equal to x can be extended to any function of random variables such as 3x, x squared, x minus 2 cubed, etc. So if x is a discrete random variable with a probability distribution function px equal to x, then the expectation of any function of x is given by, so expectation of gx is simply equal to that g times with the probability. So there are a few properties of expectation that we have to remember. Oh, but I should remind you one thing. Okay, expectation of x is equal to the sum x px equal to x. So that means if let's say you have expectation of x square, this is simply the summation of x square multiplied with px equal to x. So that is what they mean over here. This is x, this is x square. X, that is also x. X square, this is also x square. So expectation of x plus 1, this is the summation of x plus 1 and then px equal to x. Okay. Right, so there are a few properties of expectation. So this is valid for both the continuous as well as a discrete. So they are the same thing. Right, so expectation of a constant is equal to that constant. If that is a constant, expectation of a constant is equal to a constant. And then expectation of a constant multiplied with x is simply equal to that constant. So you can easily factorize those constants out. And then times with the expectation of x if you have an addition inside there, so for example, expectation of ax plus b, that is simply equal to a expectation x plus with b. So this one can be very useful when we want to calculate expectation quickly. So firstly, calculate the expectation of this, and then if let's say you have to calculate expectation of 2x, then do remember factorize the 2 out, so this is 2 times expectation of x, and then simply substitute with the value of expectation of x that you already calculate earlier. If let's say you have to calculate expectation of 2x plus 1, then this is simply 2 times with expectation of x plus with. So instead of writing down the whole formula again, we can simply use expression of x to calculate them. So dia macam short sikit lah, short sikit. Biasanya soalan dia macam berangkai. Biasanya dia minta expectation yang x dulu, baru minta 2x plus 1. So untuk soalan yang berangkai, kalau kata kita kira satu persatu nanti jadi panjang lah. Sebab tu kita guna properties lah bagi cepat sikit. Okay, next. So the above properties of expectation are true for both discrete and continuous random variable. So like I mentioned to you before, you can use them for both. Okay, so the probability distribution of a discrete random variable x is given as below. So we have x 1, 2, 3, 4, 5, 6, 4, 5. And then the probability of x equal to x 0.1, 0.3, 0.3, 0.2, 0.1. The question asks us to calculate expectation of x. Okay, so how do we calculate expectation of x? So formula for expectation of x, this is simply equal to the summation for all x, x multiply with p, x equal to x. So each x I need to times with its own probability, and then I will bring together, which means 1 will be times with 0.2 plus 2 multiply with 0.3 plus 3 multiply with 0.3 plus 4 times with 0.2 plus 5 times with 0.1. And then of course you're going to use your calculator for calculate 0.1, 0.6, 0.9, 0.8, 0.5, add everything together. So the will be equal to 2.9. So that is the expectation of x. Okay, so now let us proceed with example 4. Boleh ke ni? Takut tak ada salin je. Okay, example 4. The probability distribution of a discrete variable x is given in the table below. So we have 1, 2, 3, and then 1 over 6, 2 over 6, as well as 2 over 6. So do see that if you add the probability together, you are supposed to get 1 because that is a discrete random variable. So always check that is a discrete variable. Okay, next. We have to find out what is expectation of x, expectation of 5x plus 2, expectation of square, expectation of 5x squared plus 2, and then if y is equal to 3x plus 1, find the expectation of y. Okay, let's see which one is the easiest one. Okay, so of course we start from A first. This is expectation of 2. Expectation of 2 simply means that this is a constant, right? 2 is a constant. So if you refer to your previous page, for the first properties of expectation, E of A is equal to A. So based on the properties, E of A is equal to A. So that means if I have E of 2, this is also equal to 2. Done. And then please calculate for me what is expectation of x. Expectation of 5x plus 2, expectation of x squared, 5x squared plus 2, and then expectation of y. Okay, so saya bagi masa sikit lah dalam 5 minutes for you to calculate everything and then let us check the answer later on. Boleh 5 minutes starting from now. Kena tak, kalau tak type nanti tak tahu. Oh, hari ni lah Sabtu. Lepas ni tak ada apa. Okay. Okay. Hmm. Lain tak okey. Tak apa. Okay, so kita teruskan sebab sebelum line tu buat problem lagi besar, baik kita teruskan je. Nanti rasa macam masih nampak muka saya ni, kita teruskan je lah. Sabar je lah. Okay, so now how to calculate the expectation of x. So you simply do times the x together with the px and then add everything together. So those one will become expectation of x. Okay, so 1 multiply with 1 over 6 plus 2 times with over 6 plus 3 times with 3 over 6. So that is equal to 7 over 3. Okay, so this one just in case you guys are interested in checking that the expectation of a constant is simply equal to that constant, then you can use this formula if you want to. Okay, so expectation of x multiply with px equal to x. So 1 times 1 over 6, 2 times 2 over 6, 3 times 2 over 6. So the answer for this is 7 over 3. And then C, addition of 5x plus 2. So every time you see the here, we can actually times them by 5 and then plus them by 2 before we times with the probability. So we are going to get 5 times plus 2 multiply with 1 over 6 plus 5 times 2 plus 2 times with over 6 plus 5 times 3 plus 2 multiply with 3, 6. So this is simply 5x plus 2. This one is also 5 plus 2. This is also 5x plus 2. So I simply change the x from 1, 2 and 3. Okay, so now if we add everything together, this one should be equal to 7 multiply with 1 over 6 plus 12 times with 2 over 6, 17 times with 3 over 6. So this is 82 over 6 or 41 over 3. Of course, you can actually use the properties because we have learned how to use the properties before. So using of expectation, the expectation of x plus 2 is simply 5 times with expectation of x plus 2, which is 5 times 3 plus 2, and that is equal to 41 over 3. So basically you are going to get the same answer whether are you using 5x plus 2 times with the probability or you can use the property. So the answer is the same. Kalau untuk saya biasanya saya pilih property sebab senang sikit. Okay, next. We got a C. D is expectation of x square, right? Okay, so expectation of x square, that means for you have to square them first before you times with the probability. So this one is square, so it's supposed to be 1, 2 square is 4, 3 square is 9. So it's supposed to be 1 times with 1 over 6, 4 times with 2 over 6, 9 times with 3 over 6. Excuse me. So you're gonna times them. So 1 over 6 plus with 4 times with 6 plus with 9 times with 3 over 6. Add everything together. So that one is simply equal to 6. And then for the E, we have to calculate the expectation of 5x squared plus 2. So again, we are using some properties over here. So we got some constant. So this is 5 times with expectation of x squared and plus with 2. So expectation of x squared, we already calculated them earlier, which is 6. So this is 5 times 6 plus 2. Okay, so that is for E. F, expectation of y, if y is equal to 3x plus 1. Okay, so expectation of y, if y is equal to 3x plus 1, so I simply substitute y with 3x plus 1. So expectation of y will become expectation of 3x plus 1. And of course, you can use the properties for them. Have a 3 in front of the arrow here, so you can actually factorize out the 3. So this is 3ex plus 1. Ex 1. And then ex, we already calculate the value before. So simply substitute the value in. So this is 3 times with 7 over 3, plus, which is 7 plus 1. So that is equal to 8. So that is expression of y. So now let us go to the last one. Variance. Ada lagi 2 example tapi the last variance. Okay, next. Variance of a discrete random variable. So variance is denoted by VAR over x or sigma square and is defined as, so variance of x is simply equal to expectation of x square minus expectation of x with a square. So that means there are things that we need to calculate before we calculate the variance. So you need to calculate expectation of x first, and then calculate is the value for expectation of x square. And then once you have the expectation of x and expectation of x square, you can easily substitute into this formula. So now the standard deviation, of course, that similar to data. So standard deviation of x is simply the square root of variance of x. So the value of x is always positive because we are talking about their spreadness. The spreadness is positive. So there are some important properties of variance. Again, we have 3 properties of variance. This is true for both discrete and continuous. So this is for discrete, this is continuous. Okay, so we have 3 properties of variance. Variance of a constant is simply equal to 0. Variance of ax is equal to a square multiplied with variance of x. If we have variance of a plus b, that is also equal to a square variance of x. So that means if we have a constant, so adding or minus with a constant, that doesn't really affect our variance. They were similar. So variance of x is a square variance of x. Variance of ax minus b is also equal to a square variance of x. Okay, so let us go to the next example. Example, the probability distribution of a discrete random variable is given as follows. So calculate expectation of x, calculate expectation of x square, and then calculate variance of x. Okay, so in order to calculate expectation of x, that is equal to the summation of all x, x multiply with p, x equal to x. So we do 1 times 2 over 7 plus with 2 times 4 over 7 plus with 3 times with 1 over 7. So 2, 8, 10, 10 plus 3. So this is 13 over 7. So this is expectation of x. Expectation of x square. So this is simply the summation for all x. X square multiply with p, x equal to x. So do it to square all the x first before you multiply with the probability. So this one going to be 1 multiply with over 7 plus 2 square or 4 times 4 over 7 plus with 3 square, which is 9 with 1 over 7. So this is 2 16. So 80 plus 9. 80 plus 9 is 27. 27 betul lah. And then you easily calculate variance of x. Okay, so let me write them down in a proper way. Tulis cantik sikit lah. So I'll go to the next slide. Cantik. Biasa je, sama je kan. Okay, so expectation of x, we have 13 over 7. Expectation of x square, 27 over 7. Okay, so now the question asks for variance of x. So what is the formula for variance of x? Variance of x is expectation of x square minus expectation of x everything square. So expectation of x square, so this is 27 over 7 minus expectation of x is 13 over 7 square. So for this one, you must calculate 13 over 7. You square one first before you do 27 over 7 minus with that answer. So whatever you got, that is your variance. So I do feel that I need to go to the slide to get the variance. Okay, so let's go to the next slide. Okay, so the answer for this is 20 over 9. Okay, so do make sure to calculate the variance of x. You will need to calculate expectation of x square with expectation of x. Are two expectations that you need to calculate. Okay, so now let us go to the last. We have few, but yes, we can use the properties actually. You need to calculate the first one. Okay, so now example 6. The probability distribution of a discrete random variable x is given as follows. So we have x 1, 2, 3, 4, and then p x equal to x 1 over 16, 1 over 2, 1 over 4, 3 over 60. And now the first one, the question asks for variance of x. Of course, you have to refer to the formula. Variance of x is simply equal to expectation of x squared minus expectation of x square. Yep, Fatha, very good. That is the correct answer for the previous one, right? Okay, so expectation of x square minus expectation of x square. Okay, so you need to calculate variance of x first before you calculate the rest of them by using the properties. So calculate variance of x and then the rest you can use the properties. Variance of 2x plus 3, so this is simply square variance of x. Variance of x minus 2, this is also equal to variance of x. Variance of 5 minus x, 5 minus 8x. So this one is negative 8 square multiply with variance of x. So everything will need to for value of variance of x. So let us calculate variance of x first. Okay, so expectation of x. So 1 times with 1 over 16 plus 2 times with 1 over 2 plus 3 times with 1 over 4 plus 4 times with 3 over 6. So altogether, the answer, the expectation of x is simply equal to 41 over 16. So 1 over 16 plus 16 over 16 plus 12 over 16 plus 12 over 16. So the answer will be 41 over 16. So this is expectation of x. The next one, you have to calculate expectation of x square. So try to square each of the x first, and then you should times them with the probability. Okay, so it will become 1 square multiply with 1 over 16 plus 2 square multiply with 1 over 2 plus 3 square times with 1 over 4 plus 4 square times with 3 over 16. So the answer for this one is simply 117 over 16. And now we can substitute into the formula to calculate the variance of x. Okay, so do you remember the formula for variance of x? Variance of x, this is expectation of x square minus expectation of x square. Therefore, this one will be 117 over 16 minus 41 over 16 square. So you minus them, and that will be the answer for variance of x. Okay, so let me proceed with the next slide to calculate the variance. Okay, so now calculation 117 over 16 minus 41 over 16 square. So the value is 191 over 256. So this is actually variance of X. And then you can use the properties to calculate B, C, and D. Okay, let us go to B. B, variance of X minus 2. Variance of X minus 2, that is simply equal to variance of X. So variance AX is simply equal to A square variance of X. So as you can see over here, this is simply, so the number in front here is 1. So this is 1 square variance of X. Or you can say that also equal to variance of X. And the value of variance of X minus 2 is simply equal to 191 over 256. Okay, so now 2 more to go. C, variance of 2x plus 2. Again, we are going to use the properties. So this is 2 square multiplied with variance of x. So it will become 4 multiplied with 191 over 256. So of course, you're going to solve everything, simplify them. So this is 191 over 64. Right, the next one. D, variance of 5 minus 8x. So this one is where the mistake always comes, because you forgot that you should refer to the coefficient of x. So the coefficient of x is negative 8. So it's supposed to be negative 8 square, not 5, negative 8. Okay, so negative 8 square multiplied with variance of x. So negative 8, if you square them, it will become 64. So 64 multiplied with 191 over 256. So do make sure to simplify that. And your final answer is equal to 91 over 4. And that is basically the end of the second lecture. So I'll see you guys this Tuesday, where we are going to start with the third lecture. So hari Selasa nanti jumpa kat Dewan Kuliah semua orang. So bye-bye. Have a nice weekend. Have a nice holiday everyone. Bye-bye. Thank you for listening. Bye.